Good morning to all of you. Audible to you or no? Sorry for delay due to some technical problem. Okay. First of all, thank you for introducing me for this Atal FDP program. Okay. In the first session, I would like to discuss about this self-compacting motors with nanomaterials and innovative repair for statistics. Yeah. Okay, this thing is nanomaterials. Actually, this topic is almost related to this topic of next generation of concrete technology utilizing nanomaterials for development of strong and smart infrastructure. I am very happy and thanks to the organizers for choosing this topic related to the nanomaterials. Okay. My topic also almost related to this nanomaterials, inclusion of nanomaterials in self-compacting motors. That material should be used for repair applications, or exclusive for historical studies. Okay, then I will ask few questions. Can I ask or not? Okay, choice is yours. You can give the answer or not, yours choice. But I will ask the questions in between because some may be in browsing and some may be somewhere thinking, some are using the mobile phones. That's why I ask the questions. Anybody have an idea about self-compacting motors? Anybody have an idea about self-compacting motors? Anybody have an idea of that historical structures? I am asking the first part of the title and last part of the title. Why do we call this structure as historical structure? Anybody? Self-compacting motor means a motor which can be compacted by its own weight without any extra energy. Okay? Without any extra energy, without compromising that segregation and yield, maintain the viscosity and can be easily flow. That is advantage of the self-compacting motors or concrete also. Okay? If it can easily flow, then what is the use of that? What is the use of that self-compacting motors in the historical structures? What are the problems in the historical structures? What is the historical structure actually? The historical structure is nothing but when a structure is historically or architecturally is important and survived more than 100 years, that structure is called historical structures. Can anyone see the historical monuments, historical structures nearby Kodad? Okay, what is the situation of the structures? There are so many damages, there are so many cracks, there are so many destructions. Okay. How to fill the cracks? How to fill the cracks? Simple motor cannot flow. If you are using the self-compacting motors, it can easily flow and fill the cracks or gaps, whatever. That is the advantage of the self-compacting motor. It can easily flow and quickly hardens and gain the strength. Okay, that is the concept of the self-compacting motors using in the historical structures as a repair material. Then why the nanomaterials are required? Okay, for repair material some flab is required. Okay, Why Hyderabad biryani is famous for that? Not for Hyderabad. Some flavor. Because of some flavor, we are like that Hyderabad. Here also we are giving some flavor to the self-compact mortar, that is adding of nanomaterials. Okay, what is the importance of addition of nanomaterials? What is the purpose? Why it is required? Everything we will discuss on that. Okay, coming to the next slide, I think introduction. Already given. Okay, if the structure is sustainable up to 100 years and that structure have historical background and archaeological background, then we call it as a historical monument or ancient. Can you give me any examples? Temples, dams, domes, forts, churches, meeting halls, cemeteries, so many also. You can see that examples. These are the examples. Many, you can see that many temples are very, very old, more than 100 years also, still they are existing. Okay, you can observe that or not, I don't know. In Warangal, one temple is recently recognized by the UNESCO. Okay, Ramappa temple. Okay, our students done the research on the Ramappa temple. What material they are using in those days. They find out the characteristics of this material, mortar, and develop that similar material which can be used for repair applications of Ramappa temple. Okay, recently it was recognized by the UNESCO. Okay, you can see that there are so many ancient buildings in our India, but only 25, nearer to the 25 places are recognized by the UNESCO. Only 25 are recognized by the as a World Heritage Monuments. One thing is Ramappa. UNESCO means we studied in long back, 7th class or 8th class. United Nations Educational, Scientific and Cultural Organization. Okay. And UNESCO recognized some of the monuments. But then what is the organization to taking care of all these historical monuments in our India? ASI, Archaeological Survey of India. Okay, this organization will taking care that all the historical monuments, they will preserve that historical monuments, they can repair that. Okay, they have some rules and regulations. We cannot take any sample from that any historical temple for research point of view without the permission of ASI. Okay, for Ramappa temple also we took the permission from ASI and collected samples, some samples. Here, this ASI recognizes almost nearly 4,000 monuments or historical monuments across the India. Okay, then you know that. You know whether the repair is in historical structure or whether the repair is in our own house. What is the main repair material? Mortar only. Okay, mortar or cement paste. Whenever the crack is there, the mason put that cement paste and put the color again. That type of repair is called as cosmetic repair. Cosmetic means wherever that small gaps are there on the face or anything, you can put that some makeup. That is called as cosmetic. Okay? But likewise the structure also, any crack is there, you can put some mortar or cement paste, put that color. After that what will happen? Again crack may develop due to the so many regions. Again repair will be required. Okay? Therefore, traditional construction materials and practice are still used. Okay? We are not using any extra technology, we are not using any extra or super materials for repair of this. Not only the historical structures, any structure or newly constructed structure also we are using. You can see that some of the monuments, that structural, it is sound and structure point of view, but you can see the color changing, vegetation, growth of vegetation, and there is no proper maintenance. Okay, there is no drainage for this rainwater and all these things. Because of that one, we are intentionally or unintentionally we are creating the problems to the historical structures. Okay, and this is repair process. This is called as pointing. Okay, pointing means, okay, you know that masonry wall or any brick masonry or rock masonry, stone masonry, you are putting that in between the masonry units, you are putting some mortar. Okay, this one. Okay, in order to repair that, mortar is exposed to that environment. Okay, mortar is exposed to environment, they will damage quickly rather than that masonry unit like stone or brick. Therefore, you can remove that mortar portion and some length, some 1 inch or 2 inch mortar, remove that mortar portion and again put that good mortar. That is called a repoint. Okay, this is one of the picture. Okay, all the bricks are exposed, but this is good. Architecture is good. Okay. Likewise, some figures to identify what are the problems in historical structures. Okay, here our duty is to preserve that historical structures. Who will take care of that? Both state government as well as central government, because all this monuments, preservation of the monuments is included in the constitution. Therefore, concrete list of the constitution. Therefore, both that governments will take care of this. Okay. If you see that any historical structure, okay, based on historical structure, we can assess the what technology they are using, what is the socio-economic status in those days, what material they are using. Generally, at that time there is no cement, there is no OPC, there is no 43 grade, 53 grade. Okay, there is no steel bars also, there is no cranes also. But even though they are trying to construct the good buildings for showing their interest or showing their socio-economic status or any other things. Heritage buildings constructed in the past that have high historical, architectural, spiritual, social, political, economic values, and also that historical structures reflect that status of that in those portions. The main thing is whether it is historical structure or normal structure. Main culprit is moisture. Once the moisture is entered into that portion or any mortar, it is damaged. Okay, moisture, and one more thing is solar radiation. Some coast areas can get the solar radiation, and some of the winds also damage that structures. We cannot stop all these things. We cannot stop the solar radiation. We cannot stop wind also. Only thing is we can prepare that good material. Okay. We cannot stop the terrorists entering to the India. Kasab may enter at any place, but don't feel anything. I am giving that down. The only thing is our force should be good enough. That means our material should be good enough to shut enough. That material should not allow any aggressiveness. That material should not allow any moisture. That material should not allow any carbon, any chlorides. You can prepare the dense material as regular material as well as repair material. Okay, these are the effects, major effects. One is discoloration, abrasion, cracks, stains, fungal growth. You can see it in some of the photographs also. Okay, main thing is discoloration. Okay, another thing is cracks and fungal growth and vegetation. Okay, for example, if you can take any repair of the historical structure, if you want to take that material, okay, then you can select that material from that site and characterize that material by conducting various tests like XRD, SEM, identify what are the materials in that existing mortar. Okay, then you can prepare the similar material and test that material whether it is suitable or not. Okay? Selection of repair material is very, very important. Right. The repair materials are very absorbent. That means it will absorb the moisture. Our existing motors are old motor, therefore they can absorb the moisture. That motor may be decayed, and rising dampness is very common in areas where that water table is very high. In coastal areas you can observe that one. And the water also creating the problems. This is the major problem actually in many areas, especially in European countries. Okay. The cause of deterioration of masonry materials is the crystallization of water soluble. Water soluble means if you can take the chloride, it is water soluble and it is entered into the wires of the motor. Wires of the motor, then it will create the problems. That the motor is subjected to cracks. Otherwise, motor is exposed to like this. In the photograph, damage due to salt crystallization. Motor is damaged due to the, and this is efflorescence, that means salt damage of peak quantity of peak. These are the major problems in this salt crystallization process, and can get that efflorescence lead to decay. These are the reasons for it. Okay, in view of all these issues, all these problems, the best material is self-compacting motors as a repair material. Okay. In view of the above effect, the material should be developed, which should be passed through narrow openings, already explained in the beginning. Narrow openings and gain the strength early. That is one of the advantages. And material have more durable strength. So these are the advantages of self-compacting motors. It can easily pass through the narrow openings and settle fast, gain the strength fast, and it should be more durable. Durable means durable. Long life. That durable means the material can withstand against aggressive agents. What are the aggressive agents here? Moisture, chlorides, sulfides, or any other carbohydrates. Okay, that material should have resistance, more resistance against these materials. That material is called as durable material. Okay. Here two questions actually: high performance and high durable. High strength. All these three are same. High performance, high durable, high strength.
No, sir.
High performance means that material have more durable, more strength. High strength may not have more durable. More durable may not have more strength. Therefore, we can select that high performance concrete. Okay? If you can imagine that bullock cart, if you can imagine the bullock cart, there are two. Okay, one is moving forward, another is moving slow, it cannot go. Okay, strength and durability should be the same pace. That concrete or any material should be good. Okay. The alternative material for this repair is nothing but self-compacting motors. This flavor is nanomaterials. Self-compacting motor with nanomaterials. Then, repair and rehabilitation of heritage structures has taken a prominent role because there are so many heritage structures and we should preserve the heritage structures. We can repair the heritage structures, therefore one promising material is required. One promising material, the material should have more strength and more durability. And some of the characteristics also there I will explain in the coming slides. What are the things? Due to the application of engineers and mechanical engineering, self-compacting motors is preferred for repair purposes, especially in reinforced concrete structures and heritage buildings in these days. Okay. Yeah. What are the ingredients required for self-compacting motors? Any special thing is there? No. The ingredients required for self-compacting motors are safety, cement, and sand, and water. In order to get that flow, you can go for the superglue. Then, how to improve that flowability? In order to improve the flowability of self-compacting concrete, more powder is required. If you can go for the more cement content, what will happen? More cost. More cost. And what is the disadvantage? Okay, I can bear the cost because I have so much of money. But what is the disadvantage? If you can go for the more cement, shrinkage problem is there. That is the main. Once you can put the more cement, after casting, you can get the cracks. Again, you develop the cracks. That's why you cannot go for the more amount of cement to develop the self-compacting mortars. Okay, you can go for the lesser amount of cement, and you can add that what are the byproducts, industrial byproducts available. That is supplementary cementitious materials like fly ash, GGBS, metacolite, lysis cash, silica flute. What are the materials available there? But how to add all these materials, I will explain the afternoon session. Okay. In the afternoon session, I will explain if you can add 4 components, 4 materials, replace with the cement, how to replace it. Okay. That technology I will discuss in the afternoon session. Because the cement as well as the ingredients of the paste, mineral mixtures and organic chemical elements should be carefully chosen in order to obtain suitable paste. Because paste is very important thing for self-compacting. The rheology of the paste. Rheology means fresh properties. Okay? You can the basic principle of the self-compacting mortar or self-compacting concrete is the settling velocity of the particle is inversely proportional to the viscosity of the floating medium. Got it? Understand or not? Settling velocity of the particle. Okay? Settling velocity. For example, if you can take the concrete and leave for some time, the coarser aggregate will come down. Coarser aggregate will come down. Okay? If it is come down, you can get that bleeding as aggregation. Therefore, always the coarse aggregate should be suspended state. That's why the settling velocity of the particle is inversely proportional to the viscosity of the floating medium in which they will stay. Okay, that is the basic principle of self-compacting concrete and mortar. Therefore, in order to develop the self-compacting mortars, you should choose the materials properly. Okay, you can select the materials properly. Yeah. Then coming to the selection of repair materials. There are so many parameters. Selection of repair material is one of the most important tasks for ensuring durable trustworthy. First thing is availability of the material is within the site, within the location, and skill level is available or not. Equipment is available or not within the location. Then only you can choose that material. Okay? Some material is available in the Mumbai, but your location is Kodar, but it is very costly. Getting that material is very costly. What are the locally available material? Your fly ash is available in that Kodar. There are so many, I think, power plant is available. There's something other GGBS is available, or lysis cash is also available. You can choose that material as a repair material because only motto is you can replace the cement with other alternative materials like that is what called as supplementary cementitious SCM. Individually, they don't have any binding properties. You can take the fly ash, there is no binding. If you can take the GGBS, silica fume, if you can add that fly ash and GGBS and silica fume into the cement, you can get that positive. See, then I will give one example for selection of the repair materials. Okay? If any cloth is torn, the shirt is torn, can you patch with the same color of the shirt, otherwise other color? Same color. Can you pack the same fabric, otherwise, for example, my fabric is cotton, can you use that any wool or other silk? Therefore, you can choose that what is that raw material or strata, original strata. Based on that, you can choose the material. Just example this one. Okay? The analogy of for selection of repair material is similar to the repairing of a torn garment with sound fabric of similar performance as that of the original garment. Okay, aesthetic also very important. Aesthetic and matching. Okay, this is applicable to the selection of repair materials. Yeah, this is the main problem. Shrinkage is the main problem. Therefore, you cannot go for the higher amount of cement. Cementous products have a tendency to shrink and harden with age. Therefore, you can select that repair material that should have non-shrinkable. Okay? Non-shrink type compared with the pair. Then one by one discuss that properties here. Repair materials for cement, concrete and mortar shall be easy to apply and require no attention after the repair. This is very, very important aspect. Once I repair that one structure, after 1 month, again it requires repair. It's no use, it's wastage of money. Okay? That's why this is a very important thing here. Require no attention after the repair has been applied. If goes on repairing it, the construction cost is of original building is less than the repair cost sometimes. And that's why you can choose the material. That is very, very, very important. The parameters are, first is low shrinkage properties. The repair material should have less shrinkage. When you can get the less shrinkage? If you can add less amount of cement. Less shrinkage. Next is the requisite setting and hardening. For example, I want to repair the road, and the setting of repair material will take 24 hours or more than 24 hours. I cannot stop the vehicles. Okay, I can stop the vehicles for traffic 1 hour or 2 hours. Therefore, setting is very fast, and at the same time gaining of strength also. Setting, requisite setting and hardening properties. And third one is workability. Okay, based on this workability, we choose that self-compacting mortar as a repair material. Okay, what is the definition of workability? Everyone using that as civil engineer. Okay, workability is not so good. What is the workability? Simple way we can say that easy to work. Easy to work in all the aspects. While mixing, while placing, while transporting, and while placing, after transporting, while placing. In all these aspects, the material should be easy to work, handled with easiness. Okay? Therefore, the repair material should have more work. Good bond strength with existing software. Okay? I already one old motor is there. This is the old motor. Imagine, I will add another motor there. If you are not providing good bonding between the old and new one, then it's wastage. How to provide that bonding between these two? Okay, there are so much of bonding agents are available. You can put one coat, bonding coat, and apply that. Otherwise, no. When that old strata is in wet condition only, you can apply that. And there are also so many problems in that case. If it is old strata is dry, and they are putting that mortar, therefore what are the water available in the mortar will be absorbed by the old one. Okay, then once that water is absorbed by the old one, there is no water for hydration, no use for repair. Therefore, you should consider all these aspects while selecting the repair material. Compatible coefficient of thermal. Sometimes coefficient of thermal expansion is very, very important, because you can select the repair material in such a way that the two materials have the same coefficient of thermal expansion. You cannot take different coefficient of thermal expansion materials. Okay. Next one is mechanical properties and strength in the top strata. For example, the old concrete is M30 grade concrete, and you can add the 50 megapascal concrete, then it should not be matched. You can get that cracks again. And allow the relative movement. Sometimes in case of bridge repairs, that movement is also there. This new repair should not obstruct that movement of that any bridge deck. Okay? Particularly in case of sealing of cracks, dealing with external joints. And yes, this is also very important. The repair mortar should be minimum or no curing. It goes on curing for 28 days. What is the use? You can go for the minimum curing or less curing, because nowadays self-curing agents also available. You can go for the self-curing mortars, self-compacting, self-curing mortars also available. You can go for the chemicals like PEG, polyethylene glycol, is a self-clearing agent. Go further. Depending on the site conditions. Okay, alkali character. The prepared material should be in alkali character because the cement mortar or concrete is alkali nature, not acidic nature. Therefore, this mortar should be in alkali character. And low air and water permeability because that cement mortar or repair mortar should be more dense. All the voids should be filled. Therefore, there is no question of allowing of aggressive agents. Okay? Aggressive agents means allowing of carbon dioxide, allowing of moisture, allowing of chlorides and all those things. Okay? Next, aesthetic. This is very important. And cost and durable and non-degradable. And last one is non-hazardous, non-pollution. You cannot create that pollution again. Okay, these are the 14 important parameters for selecting of the repair materials. This self-compact mortar will have all these 14 characteristics. Therefore, you can choose that self-compact mortar as a repair material, not only for historical structure, for any structure. Then having the nanotechnology. Okay, nanotechnology means what is that nano? Where we can apply this nanotechnology? Only for cement. Is nanotechnology there in all the fields. It is there in the biotechnology, it is there in the physics, it is there in the nano elements, electronics, electrical. But nano materials we are looking here, it is for similar applications like nano silica, nano titanium, nano L2O3, nano ferrous, everything we are using. But sometimes you can get the strength, but sometimes we didn't get the strength. Okay? Depending on that material. One of the most active research areas encompasses a number of disciplines, including civil engineering and construction. But it is costly. You can use that material whenever it is required. Many scholars, okay, by the name of recent research, otherwise extra research, they are using the nanomaterials. They are adding the nanomaterials to the concrete. Okay, sometimes they can get the results, sometimes they won't get. Because there are so many problems while using of nanomaterials. Okay? One is dispersion. Nanomaterials should not be dispersed properly. Then there is no use of adding of nanomaterials. Okay? Dispersion is very important. That means it can easily mix into that cementitious materials. That is one disadvantage. Actually, that is first taking care of that one. And the next thing is, once you are adding that nanomaterials, workability may be decreased. More amount of water is required to increase the work. These are the two problems everyone should take care of while using these nanomaterials. Okay, these are the fields I already explained here. Electronics, biomechanics, coatings. Generally, coatings they are using the nanomaterials as a features. Okay. The nanotechnology concept for Portland cement composites is steadily growing. Already there are so much of literature is available. The use of nanomaterials, the cementitious materials. Most active research areas dealing with cement and concrete are understanding of the hydration of cement particles. Okay, some researchers, I don't know, they are using what are the materials available in the market and get the strength. Okay, they are using fly ash, they are using easy base, they are using silica film, everything. But they don't know what is the reason for the increase of strength. Okay, many people prepare the biryani, but taste is good, but they don't know what is the reason for that. Rice or any ingredients, that is important, more important. That olden days, they are adding all the materials available in the market and prepare the good concrete, saying that my concrete is 100 MPa strength and it is good. What is the reason for getting of 100 MPa strength? Is it based on the cement or is it based on the other materials? You must know. That's why there are so many tests are there. That is, you can check that heat flow, hydration, and you can conduct that thermogravimetric analysis, TGA, DSC. Based on that, you can show that which material is more prominent. Okay, nanosilica has been introduced to cement and concrete. Many scholars are using this nanosilica. Okay, there are two important problems. One is dispersion problem. Dispersion means intensive mechanical or ultrasonic dispersion or surface treatment are required sometimes. Okay, sometimes you can use that dispersion techniques because they are mixing properly. Otherwise, there is no use of insertion of nanomaterials. If failing to get this dispersion will cause a negative effect on the strength. It's wastage of money. Okay. Another is more water is required because the nanoparticles have more surface area. Therefore, more amount of water is required. Okay. More amount of water is required, less workable. If it is less workable, you cannot use that material as a repair material. Okay. That is the two disadvantages of using of nanomaterials. And regarding the issue of dispersion, water-based colloidal state, because that means nanosilica is available in powder form as well as in colloidal state also. Okay, better to use the colloidal state. You can avoid the dispersion. If it is powder form, the dispersion will be doubtful. One more nanomaterial is nano titanium oxide, titanium dioxide, nano TiO2. Okay. Actually, this nano titanium oxide is used for paintings, self-cleaning agent, and they can also use it for food applications also. Vacuum. Okay. Along with the advancement of nanotechnology, nano titanium was widely studied in many fields. In the field of disposing of wastewater, exhaust gases, and mechanical and durable properties of concrete also. Okay. Coming to the self-compacting mortars. Okay, we discussed what are the historical structures, we discussed what are the repair materials and what are the nanotechnology, then self-compacting mortar. As I already defined that self-compacting mortar, the name itself, it will be compacted by its own weight. We are not using any vibrator, we are not using any extra force or extra energy. That's why it is called as self-compacting mortar. It is a new technology and everywhere we are using. It's not olden days it is new, but now it is everyone is using. But you can see that literature is new technology showing like this, but it's not new. It's not new. Okay. Especially preferred for rehabilitation and repair of reinforced concrete structures. Mortars. Actually, I will go to the case study afterward, after this one or two slides. We are using that self-compacting mortars with nanomaterials. Yeah, I already told that to place the fresh mortar without any external compaction, at the same time without causing any segregation and bleeding. What is the meaning of segregation? When placing that self-compacting concrete or mortar, that materials are separated. Okay, coarse aggregate comes and fine aggregate other side, like that. That is segregation. Bleeding means if you are placing the concrete or mortar, water comes out. That means there is no proper bonding between the paste and the aggregates. If you are providing the proper bonding between the paste and the aggregate, there is no question of bleeding and segregation. In order to improve these properties, flowability and segregation, you can go for the chemical admixtures like water reducing agents. Yes. Phase-to-phase rheology of repair mortar should possess suitable properties from the viewpoint of flowability. Therefore, selection of paste is very important. Okay, selection of paste means the paste should have more viscous. Okay, then you can go for the more amount of powder. Yeah, fine materials, fine mineral mixes. Fine materials are required in this development of self-compacting mortars. Once you can develop the self-compact mortars, developing of self-compact concrete is very easy. then you can simply add that core segments. Yeah, this is already discussed here. Nanomaterials is improve that strength, improve the durability, improve the probability also. Okay. Basically, the effect of nanoparticles addition is threefold. That means there are three mechanisms. Okay. First mechanism is the average diameter of calcium silicate hydrate is almost 10 nanometer. Okay. The nanometer this much of pores. Okay. The average size of CSH gel is approximately 10 nanometer. The nanoparticle can fill the voids of CSH structure, leading to the mortar or concrete dense. Only aim is you can prepare the repair mortar or repair material that should be dense. That should not allow any aggressiveness. How it may dense? You can fill the more voids. You can fill the more voids. What are the micro level or nano level also you can fill with nanoparticles. Okay, that is the one mechanism. Next one is it will act as a nanoparticles will act as a nuclear centers and develop the CSH, develop the hydration. Because you know the what is hydration. Everyone knows the hydration. What is hydration? What is hydration? When cement particle reacts with water, then hydration starts. That means you can get that heat, that is called as heat of hydration. There are four compounds, box compounds in the cement. Can anybody have an idea about four box compounds in cement? C3S, C2S, C3H, C4F. These four compounds reacts with water and gets the CSH gel. Okay, these nanoparticles will act as a nucleation centers to increase that hydration process. That is another second advantage. Third one is these nanoparticles reacts with calcium hydroxide. Calcium hydroxide is a byproduct during the hydration. Is it good or bad? Calcium hydroxide is good or bad? It's bad. Okay? These nanoparticles reacts with calcium hydroxide and get that another CSH gel, and that size of the calcium hydroxide will be reduced. Okay, that is called as one name. Anybody knows that name? Pozzolanic reaction. What is the Pozzolanic reaction? Okay, if you are adding the fly ash to the cement or replacing the cement with fly ash, what will happen? What is the advantage of that? The advantage of that one is, what is the major part, major component, chemical composition in the fly ash? Silica. Silica is there. And DGBS also. Silica. Okay, during the hydration, you can get the CSH gel plus another product is calcium hydroxide, CaOH twice. Okay, whatever the fly ash you are adding to the cement, having the more silica, this silica reacts with calcium hydroxide and generated another CSH, that is called a secondary CSH. Okay, that is called as a Pozzolanic reaction. Therefore, you can reduce the amount of calcium hydroxide while adding that fly ash. Okay, that is the called as Pozzolanic reaction. These are the main three advantages. One is nano voids can be filled with nanomaterials, and this nanomaterials will act as a nucleation centers and increase to improve the hydration process. And third one is these nanomaterials also react with calcium hydroxide and reduce the amount of the calcium. These are the three advantages of addition of nanomaterials in the cement. Okay, one by one. Nanosilica. Nanosilica is the first product. Earlier we are using microsilica also. That is called silica film. The surface area of silica film is 20,000 meters per kg, whereas the surface area of nanosilica is 1 lakh approximately meters per kg. And the particle size is varies from 5 nanometers to 250 nanometers. Okay, here the hydrated cement particle size RCHS gel pore size in terms of nanometers. Therefore, this nanometers can also fill this pore size of the hydrated particles. That is the one of the advantages. Based on that, based on the three aspects also, we can say that okay, there is a chance to use that nanomaterials in the concrete or cement applications. Okay, based on this, okay, first you can check whether there is a chance or not. If there is a chance, only you can enter into that. Yeah. There are so many qualifications for job entry. Okay, if you have the qualification, you can ready to apply for that job. If you don't have the qualification, okay, no one is allowed to write that exam, or no one is ready to allow you to apply that post. Here, chance is there. You can use that nanomaterials. Okay. This is for next. Okay, the shape of this nanomaterials is glossy, amorphous or glossy shape. Therefore, you can easily mix it, and reacts with calcium hydroxide already explained to you. Nanosilica can control the degradation. It means blocking of water entry on account of pore effect. Then the fundamental binder system of hydrated cement, that is CSHL, caused usually due to the calcium leaching. And applications of nanosilica is also very important. The nanosilica can be applied in high performance concrete as well as self-compacting concrete or any other things. They can use it as anti-bleeding agent. It can also add and increase the cohesiveness of concrete. Cohesiveness means that concrete should cement matrix and pore saturated particles should be bonded to each other. That is called as cohesiveness. When we have the more cohesiveness, more bonding is there between the pore saturated and cement paste, and there is no question of segregation. And inclusion of this nanosilica reduce the setting time and increase the strength of. These are the two parameters we want. Decrease the setting time, increase the strength as a required. That's why you can go for the nanosilica. Next is nano titanium dioxide. Okay, the application, this is actually they are using widely used in the photocatalyst. They can use as a self-cleaning agent. Yeah, they can use in food stuff also. And they can use it as a white pigments in the paints. You can also use this nano titanium dioxide in the cementitious materials. What are the applications we have? What are the advantages we have for nanosilica? Same advantage for nano titanium, because nanopores can be filled with this material, and it will act as a nucleation for increasing the hydration, and it will react with calcium hydroxide and get that another CSH gel and increase that amount of calcium hydroxide. These are the advantages for nano titanium also. So this is the nano titanium powder. It is amorphous state, not in colloidal state. Okay, next coming to the case study. Strength and durability of self-compacting mortar with nanomaterials. Case study. I conducted this case study at Portugal. Okay. I used the European course only for cement and all the things. And this nanomaterial also used in the Portugal only. Center work is done at IST, that means Institute of Superior Technical Portugal. Okay. For that, I am taking the two mixes. I think can I give the break? Many are sleeping. Till now, if you have any doubt, please ask. 5 minutes. Any doubts? Yeah.